Hello students, today I am going to explain R and S nomenclature. RS nomenclature. RS nomenclature is mainly based on CIP rules. So what is abbreviation for CIP? Corn, Ingold, Prolog system. C for corn, I for Ingold and P for Prolog system. Corn, Ingold, Prolog system or Corn, Ingold, Prolog rules. So mainly this RS nomenclature is explained with an Fisher projection and other one is wedge-dash projection. Here necessary to discuss a few words about Fisher projection, right? So mainly Fisher projection is represented as 2D system, that means two-dimensional system in which two lines are used. One is horizontal line and other one is vertical line. Horizontal line is always towards the observer. Once again, horizontal line is always towards the observer and the vertical line is always away from the observer, right? So in Fisher projection, two important points are very important to discuss here. What is the first point here? Point number one, the carbon chain of the compound is arranged vertically with the most oxidized carbon at the top. So this is a very important point, sir. This is the vertical line, sir. This is the top of the carbon of vertical line. So this is always belongs to most oxidized carbon atom, right? The next to point number two. So what is the point number two here? This is crossed carbon, cross line carbon. This is crossed line carbon, right? Because this is the vertical line and this is horizontal line. This cross line carbon is always asymmetric carbon. Asymmetric carbon, so it is also known as chiral center. It is also known as chiral center. So what is the meaning of asymmetric center or asymmetric carbon or chiral center? The carbon is surrounded by four different groups. Once again, the carbon surrounded by four different groups like A, B, C and D. So all are different groups surrounded by this carbon. That's why this carbon belongs to asymmetric carbon or chiral center, right? So this is about Fisher projection. Now coming into a topic, that is RS nomenclature. Here RS nomenclature is understanding through two steps. Here step one about RS nomenclature: assign the priorities to the four atoms. Assign the priorities to the four atoms or group attached to the chiral center in the usual way. Number one, once again, what the first points are? Assign the priorities to the four groups attached to the asymmetric carbon or chiral center, right? So how can you bring priority with respect to these groups or atoms? Because priority is always directly proportional to the atomic number. Priority is always directly proportional to the atomic number. So more atomic number, more priority. Least atomic number, least priority. Of course, we know that in our periodic table, what is our least atomic number, sir? Hydrogen. That's why hydrogen is always least priority, right? And step two. So what is step two here, sir? Now, according to priority rules, now determine the rotation of direction. Determine the rotation of direction while going from 1 to 2 and 2 to 3. 1 to 2 and 2 to 3, right? So 1 to 2, 2 to 3. So here what is one, sir? Higher priority, second priority and third priority. Fourth is always least priority. Now coming to this one, I want to give one number for this A. So what is the meaning for that, sir? Because 1 is more priority and 2 second priority, 3 third priority and fourth one is the least priority. So here what is the least priority group here? D is our least priority. And what is the highest priority here? 1 is the highest priority. So this is the way to assign priorities to the respective of atoms or groups attached to the chiral center. Once again, sir, asymmetric priorities always directly proportional to the atomic number. So here 1 is a more priority. So indirectly what you understand here, A is highest atomic number, then B, C and D. Here what is 4? 4 means least priority. So D is least atomic number comparatively 1, 2 and 3. So this is the way. And now what is the step 2? According to priority rules, now determine the direction of rotation of molecule, given molecule, while going from 1 to 2 and 2 to 3. Right? So here you need to understand two more points here. What are the 2 points here about RS nomenclature? If eyeball moves clockwise direction, once again, if eyeball moves clockwise direction, this is termed as R configuration. If eyeball moves anti-clockwise direction, it is termed as S configuration. So according to Latin word R, which is equal to rectus, which means right. Right? According to Latin word, S is equal to sinister, which means left. So clockwise direction, right, anti-clockwise direction, yes. So it is belongs to S configuration, right is belongs to R configuration. So let us take example. How can you assign R and S configuration for this molecule? I told you already, the direction of rotation is always 1 to 2 and 2 to 3. And one more thing, sir, 4 is the least priority. Least priority never consider when you are assign R and S configuration, right? The R and S configuration is always direction through 1, 2, 3, but not 4. That's why 1 to 2 and 2 to 3, because 4 is the least priority. Least priority is always keep constant. So never consider when you choose R and S configuration, right? So here, what is the direction here? 1, 2, 2 and 3. So this is the direction here, right? So this is the rotation here. So here clockwise rotation or anti-clockwise direction? It is the clockwise direction. That's why this is R configuration. Right? This is the R configuration. And coming into, so now I am take one more example to be understanding purpose. So A, D, B and C. So here A is more priority and D is the least priority, second priority and third priority here. Right? Now what is the direction in this case? 1, 2, 3. 1 to 2, 2 to 3. So this is the direction for this molecule. So it is anti-clockwise direction or clockwise direction? It is anti-clockwise direction. That's why it is termed as S configuration. Right? It is termed as S configuration. So this is clockwise direction, right side. That's why it is R configuration. It is anti-clockwise direction, left side S configuration. Right? So eyeball moves clockwise direction, eyeball moves anti-clockwise direction, S configuration and R configuration. Right? So this is the way to understand what is RS nomenclature, right? Yes, assigning R and S configuration to Fisher projection with one chiral center, right? With one chiral center, we are going to assign R and S configuration with one chiral center, right? Here I am going to explain trick number 1 with what is our trick number 1? When atom or group of least priority is at bottom of vertical line. Once again, when atom or least priority is at bottom of vertical line. In this situation, right? In this situation, when least priority is on bottom of vertical line, so don't change, never change the structure of given molecule. We should give or assign R and S configuration according to priority rule, like 1 to 2 and 2 to 3. Because in 3 examples, take 3 examples here. Here we have 3 examples are there. In which 3 examples, least priority is hydrogen, hydrogen and hydrogen. Yes, and hydrogen is present at bottom of vertical line. Here also present at bottom of vertical line. Here also present at bottom of vertical line. That's why. So these 3 examples are, so direct you should give R and S configuration according to priority rule. Right? So here, of course, how can you assign priority numbers? Depends on atomic number. Among these 3, here it is chiral center or not? Yes, it is chiral center, sir. Why it is chiral center? Because bromine, methyl, hydrogen and chlorine all are different groups. That's why it is asymmetric carbon or chiral center. Right? So here which is among these four, which is more priority number, sir? More priority bromine, because bromine is our highest atomic number. That's why which is us, and bromine is 1, and that means more priority. And what is the next priority, sir? Chlorine. So that's why second priority. Here what is central atoms are carbon, not a hydrogens are here. So CH3. Write it like this. Central atom is carbon. So what is our carbon atomic number? 6. It is 70. That's why. So comparatively chlorine to carbon. So carbon is the least priority than chlorine. So of course here what is the least priority, sir? Hydrogen is our least priority here. Right? I told you already. So when least priority is at bottom of vertical line, so please don't consider when you are assigning R and S configuration. Always please keep constant. Right? So here what is the direction of rotation of this molecule? 1, 2, 2 and 2, 2, 3. So this is the way to direction this molecule. Right? Of course it is clockwise direction, anti-clockwise direction, sir. Anti-clockwise direction. That's why this is S configuration. Right? This is S configuration. Now coming into second example. Of course here what is central atoms are? Oxygen, and here nitrogen, here carbon. Oxygen atomic number 8, nitrogen atomic number 7, and carbon atomic number 6. So which is more priority? Oxygen. Next second priority nitrogen, and third priority carbon, and the least priority is only hydrogen. Of course I told you already, hydrogen is already present on bottom of vertical line. That's why please don't consider and keep constant when you choose R and S configuration. Right. So what direction here? 1, 2, 3. So this is the direction of this molecule. So it is clockwise direction or anti-clockwise direction, sir? Clockwise direction. That's why this is R configuration. Right? That's why it is R configuration. Now coming into this molecule. Here what is central atom, sir? Oxygen. Hydrogen. Here what is central atom, sir? Carbon. And here also carbon. Of course carbon, hydrogen and oxygen. So oxygen is more priority. And of course hydrogen is least priority in this situation. But here central atom is carbon, sir. In this group central atom is carbon. In this group central atom is carbon. CH2OH central atom is carbon. CHO central atom is carbon. So according to CIP rules, right? According to CIP rule, when central atoms are same in two groups, go for the next one. Here what are the next ones are? Oxygen. So here next ones are hydrogen. Yes or no? And one more thing in this case, here this is CHO, sir. That means carbonyl compound. Carbon to oxygen double bond, and it is single bond. But here this carbon is surrounded by all are single bonds. So according to CIP rules, double bond is more priority than single bond, because carbon to oxygen double bond, here carbon to oxygen single bond, carbon to hydrogen single bond, carbon to hydrogen single bond. That's why, so according to CIP rules, double bond is more priority than single bond. That's why, so this is the second priority and this is third priority. So what is our direction in this case? 1, 2, 3. So this is the direction for this molecule. It is a clockwise direction and anti-clockwise direction, sir. Clockwise direction. That's why this is R configuration. Right? So anti-clockwise direction, S configuration. Clockwise direction, R configuration. Again clockwise direction and R configuration. Right? So now trick number 2. Yes, trick number 2. Trick number 2, when atom or group of least priority is at top of vertical line. Right? Is at least priority is at top of vertical line. So what we are going to do in this situation? Yes. Let us take example here. So here is OH, CH3, NH2 and hydrogen. So among four, which is least priority, sir? Of course, obviously hydrogen is least priority. It is present on at top of vertical line. So what we are going to do in this situation? The entire molecule, this entire molecule rotate through 180 degree. Rotate through 180 degree. Of course, this is 90 degrees, sir. 90 degree, 90 degree, 90 degree, 90 degree. The total molecule is 360 degrees is there. But here, the molecule is rotated through only 180 degree. 180 means, sir, so 90 plus 90, 180. That's why hydrogen will appear here. Right? CH3 will appear here. OH will appear here. NH2 will appear here. So write down the structure for this molecule. Hydrogen will appear here, sir, because 90 plus 90 total 190. That's why hydrogen will appear here. CH3 also 90 plus 90. That's why here CH3 will appear here. And NH2 appear here. And OH will appear here. Now assign the R and S configuration for this molecule. Right? Here, which is most priority, sir? This is number 1. Oxygen atomic number 8. That's why more priority. Yes, center atom is nitrogen, atomic number 7. Second priority, carbon is atomic number 6. And third priority, of course, hydrogen is the least priority here. Right? Least priority is always keep constant. Right? And what is the direction in this case? 1, 2, 3. So this is the direction for this molecule. So it is clockwise direction, anti-clockwise direction, sir. Anti-clockwise direction. That's why this is S configuration. Right, this is S configuration. Yes. So second example for this trick number 2. Yes. So this molecule also, the least priority is top of vertical line. So what we are going to do in this situation? The entire molecule rotate through 180 degree, right? So here write down structure for this compound. Hydrogen will appear here. Yes, hydrogen will appear here. CHO aldehyde will appear here, right? OH will appear here, right? CH2OH will appear here. Of course, here what is center atom is the carbon only, right? CH2OH, carbon center atom. Here also carbon central atom, oxygen central atom, and hydrogen. So among these 4, which is more priorities are oxygen because atomic number 8. And next priorities are, I told you already, here CH4. CH4 means carbon to oxygen double bond and single bond. Here hydrogen, single bond and single bond. Here also single bond. That's why this carbon surrounded by single bonds, but this carbon surrounded by double bond. I told you already, according to CIP rule, double bond is more priority than single bond. That's why this is second priority, and this is third priority. Of course, this is the least priority here. I told you already, least priority is always keep constant. What is the direction for this compound? 1, 2, 2, 2, 3. So this is the direction for this compound. So it is anti-clockwise direction or clockwise direction? Anti-clockwise direction. That's why this is S configuration. Right? This is S configuration. Right? Trick number 3. So what is our trick number 3, sir? When atom or group of least priority is on horizontal line. When atom or group of least priority is on horizontal line, either left side or right side, anyone you can take for this trick number 3. That means, if for example, here hydrogen is least priority, sir, it is left side of the horizontal line. Here hydrogen is the least priority, it is right side on the horizontal line. So either left side or right side. In this situation, take opposite sign, obtain 1. That means R configuration will changes to S configuration. S configuration will changes to R configuration. Right? Opposite sign. If R is there, then will changes to S configuration. If S is obtained, so S will changes to R configuration. So this is the very, very important trick for R and S configuration when least priority is on horizontal line. Right? So let us take an example here. So among 4, which is more priorities are, of course, oxygen first priority, and second priority is aldehyde because carbon to oxygen double bond, and here next to third priority, and least priority is 4th. I already told you 4 least priorities. Please don't consider least priority when you are assign R and S configuration. Always keep constant. What direction in this case? 1, 2, 3. So this is the direction for this compound. It is clockwise direction, anti-clockwise direction, sir. Anti-clockwise direction. So that's why what is the expected configuration? S configuration. I told you already. Opposite sign we take here. S configuration will changes to R configuration. That's why here opposite sign R configuration is the correct answer for this molecule. Yes or no, sir? Next, this one. Among these 4, which is the more priority, sir? Of course, bromine, most priority. Second priority, and third priority, and this is the least priority, right? So I told you already, least priority is always keep constant. And what the direction of these compounds are? 1, 2, 3. So 1 to 2, 2 to 3. So this is the direction for this one. It is anti-clockwise or clockwise direction? Yes, it is anti-clockwise direction. That's why what is the expected configuration? Yes, configuration. But you should take opposite one. So what is opposite one here? R configuration. That's why here R configuration. You should take R configuration. Now coming into third example. So in this case, oxygen is the first priority, CH aldehyde the second priority, CH2OH third priority, and least priority is hydrogen. Of course, here right side of the horizontal line. I told you already, either it is right side or left side. So least priority is always keep constant when you are assigned R and S configuration. Right? So what is the direction for this molecule, sir? 1, 2, 2, 2, 2, 3. So this is the direction for this molecule. So it is clockwise direction or anti-clockwise direction? Clockwise direction. That's why what is the expected configuration here? R. But I told you already, R will changes to S configuration. That's why opposite side will take here. That's why S configuration for this one. Right? So this is the important trick for this RS nomenclature when least priority is on horizontal line. Yes, before I have explained the total concept of one chiral center. Now I am going to explain R and S configuration to Fisher projection with two chiral center. Fisher projection with two chiral center. So this is our example for two chiral center. In before, you have to pick up longest carbon chain for given molecule, right? 1, 2, 3, 4. So 4 is our longest carbon chain for this molecule. And if you seriously observe here, second carbon and third carbon, these two are here acts as chiral center because this is second carbon, sir. Second carbon is surrounded by CH3 group, OH group, and H group, and this is total treated as one group, right? So OH, this is one group, and H and CH3, 4 are different groups for this second carbon. That's why this second carbon is acts as here chiral center. Coming to third carbon, so third carbon also surrounded by CH3 group, Br and H. So this is treated as one group. So Br, CH3H, and this one. So total 4 are different groups. That's why third carbon is also act as one of the chiral center here. So total, so second carbon is one of the chiral center, and third carbon also one of the chiral center here. And how can you assign R and S configuration for this molecule? First of all, you should assign priorities with 4 different groups. Here I want assign for the second carbon of chiral center. Here what is center atoms are oxygen, and here what is center atoms are here carbon, because the second carbon is surrounded with this carbon and oxygen and this carbon and this hydrogen, right? So here center atom of here what is center atoms are oxygen, atomic number 8. That's why here more priority here. Of course carbon atomic number 6. Carbon atomic number 6, here also hydrogen atomic number is 4. So among these 4, 8 is the more atomic number, that's why it is high priority in this case. And coming into these two, here center atom C carbon, here are center atom carbon. Go for the next one. According to IPAC, according to CIP rules, if two atoms are same in given molecule, go for the next one. Here what is the next one? Here second priority bromine. Here hydrogen. So bromine is the more priority than hydrogen. That's why this is the second priority, right? And this is the third priority, and this is the least priority here, right? I told you already, least priority is always keep constant. And what is the direction for this molecule? 1, 2, 2, 3. So it is clockwise direction, but here least priority is at horizontal line. So that I have already told you, if least priority is at horizontal line, what happens, sir? You will take opposite configuration. But here what is the expected configuration? R configuration, because clockwise direction. But what is the Opposite configuration here, S configuration, right? Here what is the chiral center carbon? 2. That's why this is the 2s configuration, right? Because opposite configuration you should take. And coming into the coming into the next chiral center. What is the chiral center carbon here? Third carbon, right? This carbon is surrounded with bromine and carbon, hydrogen, and this one carbon, hydrogen, bromine. Among these four, which is more priority? Bromine is the first priority. And coming into the next one, here carbon, go for the next one. Next highest oxygen is highest atom is here oxygen. That's why this is the second priority, and this is the third priority, and this is the least priority here. What is the direction of this molecule? 1, 2, 2, 3. So this is the direction for this molecule, right? What are the expected configurations are here? Anti-clockwise, right? Here this is the anti-clockwise direction, but here least priority is in horizontal line. That's why you should take opposite configuration. What is the opposite configuration? R configuration. Why it is anti-clockwise direction? Expected is S configuration. What is the opposite configuration here? R configuration. What is the number for chiral center here? 3. That's why you can take here 3R configuration, right? So this is the way to assign R and S configuration with 2 chiral center, right? A few examples for this concept. Coming into this example, here 4 groups are there. One is C2H5, CH3, CH2, CH2, Cl, right? If you observe here, first atom is carbon, right? C2H5 I want to write like this: CH2 bond CH3, because to be clearly understood purpose, right? Carbon, first atom carbon. That's why according to CIP rule, if center atoms are same, go for the next one. Here, what is the next one? Here carbon. Here no carbon is there. That's why forget about this one. But here next one is carbon. Right? Carbon, next one also carbon, next one also carbon. And what about next one? Chlorine is there. But here no chlorine is there. Among all these, no chlorine is there. Only here chlorine. That's why this is the first priority. And compared to these two, here first atom is carbon, next atom is carbon. Here next atom is no carbon, hydrogen is there. That's why this is the second priority, and this is the third priority, and of course fourth one is the least priority. Always least priority is please keep constant when you are assigning R and S configuration, right? So what is the direction of this molecule? 1, 2, 2, 2, 2, 3. So this is the direction of this molecule. It is clockwise direction, anti-clockwise direction, sir. Clockwise direction. That's why what is the expected configuration for this compound? R configuration. But I already told you least priority is present on horizontal line. That's why you should take opposite one. Here what is opposite one, sir? S configuration. And S configuration. Now coming into this one. Here also. Here CH2Br, CH3, C2H5. I already told you C2H5 nothing but CH2 bond CH3. Right? Here CH3 taken 2. That means 2 methyl groups are there. One methyl group and another methyl group. Right? Of course, here first atom is carbon. That's the go for the next one. Here no one is there. But here next atom is highest. Second highest atom is carbon. Here next highest atom is carbon. But here second one is bromine. That's why this is the first priority. Obviously this is second priority. And this is the third priority. Now it is fourth one, it is least priority. But what is the direction for this compound? 1, 2, 2, 2, 2, 3. So this is the direction for this compound. So clockwise direction is or anti-clockwise direction? It is anti-clockwise direction. That's why yes configuration. So you need to observe here, sir, least priority is bottom of vertical line. Trick number 1. So when least priority is present on bottom of vertical line, so don't change the given structure. You should give direct configuration according to priority rule, right? Then coming into this one, this is 2 chiral center example, right? For first you should give, you should bring longest carbon chain here. 1, 2, 3 and 4. Of course 4 is the longest chain here. Second carbon is chiral center and third carbon is also one of the chiral center. We have 2 chiral centers are there. So now I am going to give configuration for second chiral center. Second carbon of chiral center. Here oxygen is the first priority and COOH and this is second priority, and this is the third priority, and fourth one is the least priority here. What the directions are? 1, 2, 3. So this is the direction for this compound. What are the expected one? Expected one is S configuration, but here least priority is horizontal line. That's why you should take opposite one. That means anti-clockwise direction, S configuration, but what is center? What is the number for chiral center? 2. So what is the configuration for this one? 2R configuration, because actually expected is yes anti-clockwise direction, I mean S configuration, but opposite one is R configuration. The 2 is belongs to second carbon, that means second chiral center. And coming into third chiral center here, 1 is the first priority, second priority, of course this carbon is third priority, and this is the fourth one is least priority. So what is the direction for this one? 1 to 2, 2 to 3, right? So this is the direction for this compound. So what is the expected, sir? Is it anti-clockwise or clockwise direction, sir? It is also anti-clockwise direction. So what is the opposite one? Because here also least priorities are present on horizontal line. That's why you should take opposite one. So 3R. Why 3R? Because chiral center is carbon is 3. So 3R and 2R configuration for this compound, for this example. So 2R and 3R configuration. I will make next video for RS nomenclature to wedge dash formula. Thank you.